lines in chapter 4. And we already know that parallel lines are two lines that never ever intersect, right? And then we also learned one day that parallel lines have the same what? Slope, okay? So as far as algebra goes, that's probably the most important thing that we need to know about parallel lines is that they have the same slope, okay? I'm teaching about parallel lines in geometry right now. You also need to know in geometry that they have the same slope, okay? So my geometry class before the end of the week is also going to be writing equations of parallel lines. So what they're going to do is they're going to give us some information about a line and another line. Because for lines to be parallel, you got to have two of them, right? Okay? So they're going to give us some information about both lines, and then we have to write an equation for the other line. All right? So this one wants to write the equation of a line that goes through the point -3, -5, and it wants us to be parallel to this line. Now, these are two separate lines. There's one line that goes through this point, and then there's another line that has this equation. Okay? Y'all with me? So I want the equation of the line that goes through this point. All right? And I need the same two things as I needed yesterday. I need slope and y-intercept to write that equation. Right? So that's why I have skipped to section 5.5. We'll go back and do 3 and 4 later. But I wanted to do all the slope-intercept form stuff together. Just to keep it, where our brains are not going 50 directions. All right. So, did they give me any information I can use? Cole. Yeah, this is in slope-intercept form, isn't it? Right? So I should be able to look at this line and pick out the slope. So what is this equation's slope? This slope is 3, right? And if our line that goes through that point, -4, -5, or -3, -5, my bad, is parallel to that line, what's that one's slope going to be? 3 also. Y'all with me? So if you know this one's slope, you know what our slope needs to be. Got it? Okay, so our slope will be 3. What else do I need to get that equation? The y-intercept. How do we get that? Right, you plug your coordinates, x and y, into what equation? Y equals mx plus b. Okay, so I looked at their equation, get their slope, and since we're parallel, I use the same slope in my equation. Okay? So what goes in for y? -5. What goes in for m? Answer A. Plus b. What's 3 times -3? So -5 equals -9 plus b. Now what? Add 9. What is -5 plus 9? 4 is my b. Here's m. Here's b. What's my equation? Okay, so you can double check yourself. When you write your equation, they should have the same number slope, but different y-intercepts. Is that true? Yeah. What happens if they have the same y-intercepts? Are they parallel? They're the exact same line. They're the same line. Yeah. So if we get everything the same, then they're the same line. They're not parallel. Okay? So parallel lines have same slope, but different y-intercepts. We good? That's it. You seriously look at that equation they give you, you get their slope, and then write your new equation. All right, this time we want the equation of the line that's going through the point 4, 6 and is parallel to the line 2y equals 5x plus 6. Is that equation in slope-intercept form? No, so I cannot look at it and tell the slope just yet. I have to get it equal to y. So how do I get that equal to y? Divide by 2. So that cancels. So y equals what? 5/2x plus 3. Simplify everything. So any questions about how I got that in slope-intercept form? Now do I know the slope of that line? What's the slope of that line? 5 over 2. And if our line that goes through the point 46 is parallel to that line, what's our slope going to be? 5 over 2 again. Very good. Slopes are the same when they're parallel. So how do I get my y-intercept? Y equals mx plus b. And then I plug everything in. What am I putting in for y? 6 equals, what's my m? What's my x? What is 5 over 2 times 4? 20 over 2, which is 10. Good. Did I even need to punch my calculator? And now what? 10. 6 minus 10 is negative 4. So what's my equation? 5 over 2x minus 4. And double check. Same slope, different y-intercepts. So is this terrible? Not at all. I think yesterday was even worse because this one at least the slope comes quick. Y'all try that. Oh, it was too easy. Y'all try that one. Through the point 2, negative 11, parallel to y equals negative x plus 5. Y'all, can x be a slope? No. It's the number in front of x. When you have your equation, check it with somebody. That one went quick because it's already in slope-intercept form. All right. Is their equation in slope-intercept form? What's the slope of this line? Their slope is negative 1, and if we're parallel to that line, our line will also have a slope of what? Is everybody okay with negative 1 being slope? So then you use y equals mx plus b for your ordered pair. What goes in for y? 11. What goes in for m? What's x? Plus b. What's negative 1 times negative 2? 2. What do you do? Subtract 2, and I'm out. And what do we get for b? 9 equals b. What is our equation? plus 9. Or you could leave the 1 off and just have negative x, right? So raise your hand if you got one of those two equations. Very good. So parallel line equations are easy, aren't they? They are, because they're the same slope. You know one slope, you know the other slope. Now let's talk about perpendicular. Perpendicular lines. Do they intersect? Do they intersect? Yes. But all lines intersect. Y'all listen to me, seriously. All lines will intersect eventually as long as they're not parallel. Okay? Every line will eventually intersect except for parallel lines. So any lines that have different slopes will eventually intersect each other. Perpendicular lines are special intersecting lines because if the lines are perpendicular to each other, when they cross each other, they form a right angle. Okay? When they intersect, they make a right angle. So if somebody asks you what a perpendicular line is, don't just say they intersect because all pairs of lines will intersect if they're not parallel. Okay? So perpendicular lines intersect to form right angles. And there's also something we need to memorize about the slopes of perpendicular lines. Okay? Their slopes are not going to be the same because that would be parallel, but their slopes are negative reciprocals of each other. Sometimes you hear it said opposite reciprocals. It's the same thing. Okay? So if the slopes are opposite or negative reciprocals, that means you flip the fraction, change the sign. Flip the fraction, change the sign. Flip, fraction, and change the sign. So that's what a negative reciprocal is. You flip the fraction and change the sign. So let me do a few examples for you. 2/3. Say our slope of one line is 2/3. So the slope of the line perpendicular to that line, I flip the fraction, 3/2, change the sign. That was positive, I make this one negative. Okay? Flip the fraction, change the sign. So there's one example. So what about if I have the fraction -1/2? What's the opposite reciprocal of -1/2? +2/1, which equals just what? 2. Right? Likewise, if we have a whole number, let's say our slope is 5, how would I get the reciprocal of that? Yeah, you can put it over 1, and that would be -1/5. Does that make sense? So if it's a whole number, put it over 1 and then flip it. Okay? So to get the slopes, we're going to flip them, change the sign. Even if it's a whole number, put it over 1 and then flip it. All right? All right. Now we're going to write equations of perpendicular lines in slope-intercept form. Are our slopes going to be the same? No. Now tomorrow we have a quiz, y'all. Tomorrow we have a quiz. Writing equations of parallel and perpendicular lines are on the quiz. Read the problem carefully. If it says parallel, you want the same slope. If it says perpendicular, you want negative reciprocal slope. Okay? So read the problem carefully. All right? Some people just see the P and do parallel when it's supposed to be perpendicular and vice versa. So be careful. So y = 2x + 3. Is their equation in slope-intercept form? Yes. What's their slope? Their slope is 2, right? If our line is perpendicular to that line, then what does our line need to have a slope of? Put it over 1, flip it, change the sign, -1/2. So does everybody understand why our slope needs to be a -1/2? Because we're going to be perpendicular to that line. Okay? So I'm going to use y = mx + b. and get my b, and then I'll be finished. So my point is 4, -5. What is the y value? What's my slope? -1/2. What's my x? 4 plus b. What's a -1/2 times 4? So -5 equals -2 plus b. Then what do I do? Add 2 everywhere. -5 plus 2 is what? -3 equals b. So my equation of my perpendicular line is what? -3. And then when you finish, double check and make sure that your slopes are opposite reciprocals. Because, I wrote down the original slope. Just make sure when you're copying and filling in the answer, you plug in the right one. Okay? I'm just telling y'all that because I've seen lots of common mistakes in 12 years. All right, y'all ready? Y'all good? So, y'all, this is it. Y'all, we're doing the same thing over and over. Either we're doing the same slope or opposite reciprocal slope. Same thing. Oh, and this one's already, I should have put some that were not already in slope intercept form. Challenge you guys a little bit more. But y'all are good, right? Y'all can put stuff in slope intercept form, right? I don't know. I looked at y'all's tests already. All right. So their line is in slope intercept form. What's their slope? 1/3. So our line is going to be perpendicular to that line. So what do you think our slope will be? Flip it, change the sign. That'd be 3/1. Change it to a -3/1, which is -3. So does everybody understand why our slope will be -3? We good? Y equals mx plus b. What goes in for y? What goes in for m? X plus b. And what is -3 times 4? -2 equals -12 plus b. And then what? Add 12 to either side. What's -2 plus 12? 10. So I've got m and b. What's my equation of this perpendicular line? All right. And then I'm going to double check in, making sure I have opposite reciprocals because they ask for perpendicular. We good? Nobody's lost out in the dark? Y'all are just bored to death. This is so easy. Yeah. Okay, good. You try this one. All right, you can check your equation with somebody. All right, y'all. How do I do this? What do I look for first? The slope of their line. Is it in slope-intercept form? What's their slope? So if our line's perpendicular to that line, what's our slope need to be? Any questions on why we should use -2 for our slope? Is that good with everybody? Oh, I have y'all frozen. I'm so sorry. That's what I get for looking ahead. All right, so I'm going to use y equals mx plus b. What goes in for y? What goes in for m? What goes in for x? What's -2 times a? -16 plus b is, how do I solve that for b now? Oh, -16. What's 6 plus 16? I'm graphing that one. That's a tall y-intercept. So what's my equation? Raise your hand if you got that. Did y'all think that 22 was too big, that you couldn't get that number? Did anybody freak out? Okay. Well, okay, if we're just writing equations, don't freak out if you get a big y-intercept, because we're not graphing it. We're just writing an equation, okay? So if you get a big number, it's okay. It's okay. All right. Last thing we're going to do is compare some lines. Okay? So go ahead and copy these down, please. They give us 3 lines, and we have to determine if any of them are parallel or perpendicular. So copy those 3 equations down. Okay, so how do we know if lines are parallel? They're same slope. How do I know that lines are perpendicular? Not just different. How are they different? Yeah, but what do I know about their slopes? Negative reciprocals of each other, right? You can't just say they have different slopes, because all lines have different slopes that aren't parallel, okay? So perpendicular ones are special, and their slopes are opposite reciprocals, okay? So I need to find the slopes of all 3 lines. What's the best way to get all those slopes? Yes, put them in slope-intercept form, okay? So I'm going to find the slope for all of them, and then I'll compare last, okay? Line A made it easy for us. How? It's already in slope-intercept form. So what's the slope of line A? Their slope is 5. Okay? So the second one, it says x plus 5y equals 2. That's not in slope-intercept form. So I need to make it look like y equals mx plus b. So what do I need to do to that one first? Subtract 1x. And then I get 5y equals what? Negative 1x plus 2. And then what? Divide everything by 5. Y equals negative 1/5 x plus 2/5. And their slope is what? Negative 1/5. Now I can already compare those two, but I'm going to wait till I do all 3 of them, okay? Because there might be something extra that happens. So any question on getting line B in slope-intercept form? All right, now let's do the same thing for line C. How do I get it in slope-intercept form? Add the 2x. Yeah, these are in a different order, but that's okay. So I'm getting negative 10y equals 2x. Now you can put plus 0 or you can leave that off. All right? Because the y-intercept is going to be 0 on this one. Now what? Divide by negative 10. So y equals, simplify that for me. What do you get? Negative 1/5 x. And what's their slope then? And it's okay that there's not a b right there because what is the b? 0. Okay? So that one goes through the origin. All right. So now that I have all three of my slopes, I can compare the lines. One pair is perpendicular. Is it just one pair perpendicular? You meant parallel. Okay, so what two lines are parallel? Line B and line C are parallel. How do we know that? They have the same slope. So lines B and C are parallel. No, B and C aren't perpendicular. So you can't say they're all perpendicular to each other because B and C are not because they never cross. So what lines? Okay, tell me something that, okay, what's perpendicular? Give me two that are perpendicular. A and B, because if I take 5, put it over 1, flip it, change the sign, I get negative 1/5, right? So A and B are perpendicular. What else can I say? A and C are perpendicular. Now, that's not always going to happen. So when you're doing your worksheet here in a little bit, you might just have one set of parallel lines, or you might just have one set of perpendicular lines. This problem just showed you parallel and perpendicular, okay? So get all your slopes where you can see your slopes and then compare from there. It could be where they're neither parallel or perpendicular. They're not any of them the same, and they're not opposite reciprocals of each other. So if that's the case, you will say neither, okay? Neither. All right, so that's the end of section 5.5.